An AC condenser fan motor can be the correct voltage and still be the wrong replacement. If the blade sits too high, too low, backward, or off-center, the outdoor unit can recirculate hot air, rub the shroud, overload the motor, become noisy, and lose heat rejection capacity. The repair succeeds only when the motor, blade geometry, electrical architecture, airflow direction, and complete outdoor unit operation all match. First, identify what you are servicing. The condenser fan is in the outdoor unit and moves ambient air through the condenser coil. It is not the indoor blower, and it is not the compressor. A standard air conditioner rejects heat outdoors, a heat pump reverses refrigerant flow and may use different fan controls across heating, cooling and defrost. Record the exact unit model, serial number, refrigerant, wiring diagram and operating mode before diagnosing. Do not condemn the motor from a stopped blade. A qualified technician should follow the unit sequence and separate loss of supply, contactor or control faults, a failed run capacitor on a PSC system, an open protector, damaged wiring, seized bearings, a blocked or damaged blade, and coil or airflow restriction. Some outdoor fans are electronically controlled and do not use the same capacitor or test path. Never assume wire colors, terminal names or capacitor connections from another unit. Build a replacement passport. Match the approved motor or assembly, voltage, phase, frequency, full load current, power, speed, rotation viewed from the stated end, PSC or electronic control architecture, required run capacitor where applicable, thermal protection, shaft diameter and length, mounting pattern, environmental rating, lead or connector, ground, and allowed control method. Also record blade diameter, pitch, hub direction, shaft position, height in the shroud and discharge direction. Outdoor units can contain lethal line voltage and charged capacitors. Turn off every power source, apply the applicable lockout or tagout procedure, verify de-energization with appropriate rated equipment, and handle stored electrical energy according to the exact service procedure. A thermostat setting or pulled disconnect is not proof by itself. Refrigerant circuit work, live measurements and capacitor testing belong to qualified professionals. Never short a capacitor with a screwdriver. Before removal, photograph the control compartment, motor leads, ground, capacitor terminals, connectors, strain relief, blade hub, shaft projection, motor bracket, and grille. Measure the installed blade position from the manufacturer's stated datum, not from a bent cover or a guessed visual reference. Mark which face of the hub points toward the motor and record the airflow direction. These dimensions are the repair's geometry passport. Do not treat a fan that looks similar in a catalog as repair evidence. A generic product view cannot establish the actual unit wiring, control architecture, shaft position, or installed blade datum. The unit plate, manufacturer wiring diagram, approved parts data and measurements taken from the real installation must control the repair. Follow the exact unit removal order. Remove the top grille or fan deck only after isolation. Support it so wiring is not stretched. Loosen the blade set screw with the specified tool and remove the blade without bending the hub or striking the coil. Support the motor so it cannot fall into the condenser coil. Disconnect only documented leads and connectors, then remove the bracket fasteners and motor. Inspect the blade before reuse. Cracks, bent blades, a loose hub, corrosion, impact damage or balance weight disturbance require the correct replacement. Install the motor with the specified hardware and orientation. Route leads away from the blade and hot tubing, restore protective ground and strain relief, and form the required drip loop. Transfer the blade only when approved, facing the correct direction, centered in the shroud and positioned at the exact model-specific height. There is no universal blade height or set screw torque. Electrical restoration depends on architecture. A PSC motor must use the exact run capacitor value and voltage rating specified for the motor and unit. A dual capacitor must return every wire to the documented terminal. An electronic motor may use power plus a control harness, address or programming step. Never substitute a capacitor by appearance, leave an unused lead exposed, or connect several addressable replacement motors before the procedure allows it. Before energizing, hand turn the blade with power isolated. Confirm full circle clearance, no wobble, secure hub and motor, protected wiring, centered grille and no tools in the cabinet. restore all panels and guards. Then perform a controlled run, prove correct rotation and discharge direction, smooth starting, stable speed, normal sound and vibration, motor current within the applicable data, and strong unobstructed airflow through the coil. Commission the refrigeration system, not just the fan. A qualified technician should confirm coil condition, compressor and fan sequence, operating pressures and temperatures under the applicable procedure, and correct operation in every commanded mode, including heat pump defrost when relevant. Stop if the fan rubs, cycles on protection, moves air the wrong way, or the unit develops abnormal pressure or temperature. Finish with a traceable record, unit plate, old and new motor data, capacitor or electronic control details, wiring photos, blade direction and height datum, shaft and mounting dimensions, fastener checks, current, rotation, vibration, airflow and operating results. For an OEM replacement review, send that evidence and the complete outdoor unit duty to longwellfans.com/contact.